So good afternoon, everybody.
Good afternoon, sir.
Good afternoon. Is the shared screen visible to you?
Yes, sir.
Okay. So we will continue with the topic Sun-Earth relation. Okay, angle relation. Why we are studying this topic? What is the need? Jidesh Joel. Idesh. Idesh. Idesh, am I audible to you? Jatin. Yash
Yes,
Sharma.
sir.
Jatin, why we are talking about this topic? What is the need?
Because by this topic we can estimate the solar radiation available on the Earth's surface.
Okay, very good. That means we are interested to have a study of solar PV, right? Solar photovoltaic systems. For that, we need how much solar radiation energy is available on Earth. It is a fluctuating and varying energy source, right? So we have to estimate it using some relations. For that, this angular relations between Sun and Earth is needed. So last class we have discussed so many angles, right? 5 to 6 angles we have pointed out. Can anybody recall the name? What are the angles?
Latitude angle, longitude angle, hour angle, declination angle, tilt angle.
Declination angle, tilt angle. Then some more are there. Zenith angle.
Zenith angle, incident angle, azimuth
Incidence angle.
angle.
Surface azimuth angle and solar azimuth angle, right?
Solar azimuth.
So this PDF describing these angles I have uploaded in VTOP. Has everybody gone through this PDF? Yes or no?
This PDF
Please raise hand. How many of you have read the PDF?
Sir, this PDF is not in VTOP.
It is not there. I have uploaded, I think. This PDF is
No,
not
sir,
there.
it's not.
Data book is there.
Yes, sir, data book is there.
Okay. So this PDF, in data book you will get the angle equations, right? Its description is there in this PDF. I will upload today. You can read it. Okay. So all the data is not needed either in the data book or in this PDF. Whatever we are discussing in the class, it is needed for your course. So you can take your own note in your notebook. Okay. It will be helpful for your open exams also. So whatever we are discussing in the class, that only will be tested in the final exam as well as in the CAT 1, CAT 2. Okay. So we will continue with this angular relation topic. So declination angle, what is the declination angle? Is the angular displacement of the sun at solar node with respect to the plane of equator, right? So we are getting different seasons on Earth. At different seasons, availability of solar radiation is also varying, right? Winter in our location, we have relatively less solar radiation compared to summer. Why it is occurring? Because of the variation in declination angle. Because Earth is revolving and also rotating the sun, so that angle, it is substance with the angular displacement, the sun and at the solar node with respect to the plane of equator varies. Okay, so that variation also we can see in this picture, right? At different climatic condition. June we have some declination. December another one. September. Okay, this picture depicts that. So we can read here, the variation of the declination angle over an year is shown here. The maximum declination is on summer solstice, that is June 22nd. That means 23.45 degree maximum declination. And the minimum on winter solstice, that is December 21st, minus 23.45. And this angle is 0 at equinox. What are all the equinox? 2 days per year, March 21st and September 22nd. So these days we will have maximum solar radiation on our latitude, this place, right? Okay, so this indices that the sun is directly overhead the location between 23.45 north and 23.45 south. So sun can have appear overhead between these two latitudes, 23.45 north and 23.45 south. Above and below this, that means towards polar region, sun will always appear some not overhead, the faraway place. So that location, the solar radiation will be apparently low. So we know that Arctic region, etc., full of ice. Why it is different climate? Availability of solar radiation is very less. So this equation you can note down to your notebook. Declination angle, it is also varying on daily basis. That variation is given by delta is equal to 23.45 sine 360 into 284 plus n by 365 in degrees. So n is the day number. So as I told, day number means starting from January 1. January 1 is 1, January 30, 30, then February 1, 30, January 30, 31 is there, no? So January 31, February 1 means 32, then February 2, 32, like that it goes. Okay, cumulative number. So this equation you can note is needed for your calculation. You can note down to your notebook. So at a different day, we will have a different declination angle given by this equation. So yearly variation, you can see minus 23 to plus 23.45. So two equinox, March 21st, September, that is declination angle 0. Then the maximum is solstice, that is minus 23 plus 23. So this, I think, declination angle is clear to you, I hope. Next angle is zenith angle, theta z. Is the angle subtended by the vertical line to this zenith. That is the point directly overhead. Zenith means directly overhead. So suppose sun is some away, not overhead. What is the angle subtended by vertical to the solar rays? To describe the sun's path across the sky, one need to know the zenith angle and the sun's position related to north-south axis, that is azimuth angle. So if we want to locate the sun's position, we need sun's path across the sky. We need to know the zenith angle as well as the azimuth angle. So what is azimuth angle? It is a projection. Yesterday we have seen the figure, no? Suppose solar rays is coming to a location, it can we can have a projection of that line joining the location and the sun on the earth's surface. So due to south axis, we can measure that angle, projection angle on the surface. So that is called solar azimuth angle. So solar azimuth angle gamma s is the angle on this horizontal plane measured from the south of the horizontal projection of the sun's rays. Otherwise, it is the angular displacement from the south to the projection of the beam radiation on the horizontal plane. So this angle is used to locate the sun. Okay, solar azimuth angle gamma s is there. If you are interested in a surface like a solar panel, the panel may not be always in line with the surface. It can be at a tilt angle also. So we can define another azimuth angle, surface azimuth angle, that is normal to the selected surface, we can draw a line, right? That line will have a projection on the horizontal plane. So how much this projection makes with the south axis? That is the surface azimuth angle. These are all defined in order to have some correlations for estimating solar radiation. Okay, so it may give you a confusion at this time, but you can read this PDF to get more information. Gamma and gamma S. This picture shows this one, right? Surface azimuth angle is the angle measured on the horizontal plane from the due south to the horizontal projection of the normal to the surface. It is also given as the angle between the local meridian and the horizontal projection of the normal to the surface. Then altitude angle is there, alpha. Is the angle on the vertical plane between the sun rays and the projection of the sun rays on the horizon. Altitude angle we have already defined, no? So it is alpha 90 minus theta z. Theta z is zenith angle. Okay, by trigonometry you can get this relation. Then incident angle means the angle between the sun's direct rays and the normal to the surface. At what angle the sun rays come and impinge on a surface on the earth? That is the incidence angle. Okay, between normal to the surface and the sun's direct rays. So theta. So this relation is there. Cos theta is a function of declination angle, sine delta, sine phi, cos beta, a long relation, right? For a general any surface. Okay, this is the relation. So you can see incidence angle is a function of declination angle, latitude angle, tilt angle, azimuth angle, omega, that is our angle. So these four angles are there, right? So this relation also you can, it is there in the data book. You can note down to your notebook also now. Okay, no need for derivation. By trigonometry, people have derived it. For your course, it is not. There is no need for any derivation. You can directly use this equation. This long equation is not needed. You will be asked to calculate any horizontal surface or something like that. Okay, what is the solar radiation available on a particular day and locality? So you can use the simplified equation. If the surface is horizontal, that means beta is equal to, what is the beta? Horizontal surface means beta how much? 0 or 90? Anybody? Horizontal, this is the beta, right? With the horizontal, how much is the selected surface making an angle? So horizontal means beta 0, right? So you can put cos 0, 1, right? So the equation get simplified. Cos theta is equal to cos theta z is equal to sin phi sin delta plus cos phi cos delta cos omega. So this is a simplified equation for a horizontal surface. This is also given in the data book. Okay, so this equation also you note down into your notebook. It is needed for our calculation. For vertical surface, beta is equal to 90 degree. So you will get another relation. Okay, cos theta is equal to minus sin delta cos phi cos gamma plus cos delta sin phi cos gamma cos omega. Okay, so vertically we don't keep any object usually. So this relation is seldom used. But this one, first one is used often. Okay. Another angle is sunrise or sunset hour angle, omega SR or omega SS. Okay, what is the definition? It is the hour angle at the time of sunrise or sunset. It is hour angle when the altitude angle is 0. That means we have a relation. What is the relation? day length, another term is day length, is the time between sunrise and sunset. The relationship for sunrise and sunset, hour angle and day length could be obtained from the relation of zenith angle theta z, which gives the angle between sun's rays and the normal to the horizontal surface. Therefore, a sunrise and sunset, at sunrise and sunset, the zenith angle is 90 degree, and the corresponding hour angle are denoted as sunrise hour angle and sunset hour angle. So we have the concept of day length, how much time the solar radiation is available. That is given in terms of hour angle. Sunset hour angle and sunrise hour angle. Okay. Availability of solar radiation on Earth's surface depends upon the time between sunrise and set, right? So this relation holds for that. Cos theta z is equal to 0 is equal to cos phi cos omega cos delta. So from the first relation corresponding to the sunset and sunrise, if we put cos theta z is equal to 0, we will get our angle omega is equal to cos inverse minus tan delta tan phi. This relation is also needed. Okay, estimation of solar radiation. It depends upon how much time the solar radiation is available on Earth. So solar radiation will be available at varying time at different locations. So that is the function of declination angle and latitude phi. So that is given by this relation. So this relation also you take into your notebook. So day length is given by 2 by 15 omega s. Omega s is given by cos inverse minus tan delta tan phi. So day length means how much is the how much time in hours solar radiation is available. So 15 hours of 1 hour is equal to 15 degree of solar movement, right? Rotation. So day length means 2 by 15 omega s. S is equal to 2 by 15 cos inverse minus tan delta tan phi. This relation is also needed. Is it clear to you? Abhinash Shah.
Sir, how we get that day length is 2 ws?
Day length 2 ws. Here in the hour angle, this omega s, right? Is it clear? Omega is equal to minus cos inverse minus tan delta tan phi. Is it clear to you?
Yes, sir.
This we are getting by putting cos theta z is equal to 0 in the first relation. Okay, this relation. We will get this one. Okay. So we know that 1 hour time duration is equal to 15 degree of earth rotation, right? So one day length will be equal to 2 omega s. 2 omega s, it is defined like that. Day length is equal to 2 times hour angle, sunset hour angle. Okay, so sunset hour angle is this cos inverse minus tan phi tan delta, and 1 hour is equal to 15 degree. So we will get 2 by 15 cos inverse minus tan phi tan delta. Day length. That is in hours. This omega s is in degrees. So we want in hours. Okay, how much is the day length? Day length means in a simple term, how much time the solar radiation is available. We don't want it in degrees. Okay, it will be confusing. No, solar radiation is available in say 60 degree, something like that we are telling means it is meaningless to us. So if you want to express in terms of hours, we have to convert this degree into hour. So by using this relation, one day length is equal to 2 omegas and 1 hour is equal to 15 degree of solar rotation. We will get this relation 2 by 15 cos inverse minus tan delta tan phi. Right. Derivation is not needed for you. You only understand the equation. So this is the theoretical maximum number of daylight hours. Okay. Usually the actual number of daylight hours would be less than this theoretical. So this is the theoretical maximum. By this expression we are getting maximum availability will be less than this theoretical maximum due to various reasons of cloudiness. All these things are there. Air mass we have already discussed. What is air mass? Air mass m is the ratio of the optical thickness of the atmosphere through which beam radiation passes to the optical thickness of the sun where at the zenith. So last time I saw a picture, no? At morning the rays will have to traverse more distance in the atmosphere to reach a location. So intensity is less, right? If it is at overhead, we will get more intense solar rays because it will have to traverse less. So that is given by air mass. M is equal to cos theta z inverse, right? Theta z is the zenith angle. So this is another solar radiation components. So solar radiation, electromagnetic waves, we in the first class described, right? What is electromagnetic waves? It constitute of, we can express in wavelength as well as frequency. So wavelength variation and energy, corresponding energy you can see in this picture. So most of the energy is available in the visible spectrum. Visible spectrum, VIBGYOR, you can see here. Okay, and beyond the VIBGYOR we have the infrared and other spectrum. So there the comparative energy is less. So most of the energy we are getting in the solar spectrum is in the VIBGYOR region. So with this, we will go to the estimation part. So what is the estimation? So we have the solar constant is the one term is there, ISC. That means at the extraterrestrial region we can expect almost constant solar radiation. That is 1.37 like that watt per kilowatt per meter square, like that range we can get. But when it comes to earth surface, due to various interferences, due to cloud, dust, other particles, we will get a varying amount. So this ISC dash accounts for variation of the ISC with respect to day. Okay, there is variation of the solar constant also on different time of the day. So it is this equation accounts for that. ISC dash is equal to ISC into 1 plus 0.033 cos 360 n by 365, where n is the day of the year. Then we have the direct beam and diffuse radiation. Direct or beam radiation, diffuse radiation and global radiation. So direct radiation plus diffuse radiation is equal to global radiation. We have seen in the previous class. Then irradiance, insolation. Insolation means the energy, right? Radiation, we have the energy as well as power, right? Watt per meter square, etc. means power. Energy means joule. The difference we have already described, no? Last class. So insolation means is the incident solar energy per unit area of the surface found by integration of irradiance. That means power over a specified time. So power into time means energy. So this term, difference in term meaning you note down. Okay. Insolation. So irradiance means power. insulation means energy. Measurement we will see in the coming class detail. We have already described solar measuring instruments are there, pyranometer, pyrheliometer, these things. Its working we will see in the detail in the coming class. Now you can take this these terms. Okay, monthly average daily global radiation. We are interested to estimate average global radiation, that means total radiation on a surface. So we can have a correlation. So for that we will define this terminology. Hg dash is equal to monthly average of the daily global radiation on a horizontal surface at a location. Its unit is kilojoule per meter square day. Then H0 dash, monthly average of the daily extraterrestrial radiation which would fall on the horizontal surface at a location under consideration. So Hg means global radiation, H0 means extraterrestrial radiation. So extraterrestrial radiation, we can have another equation. What is the equation for extraterrestrial radiation? This is the equation. You can note down. H0 is equal to 24 by pi ISE into 3600 into bracket 1 plus 0.33 cos 360 n by 365 into again bracket omega s sin phi sin delta plus cos phi cos delta. So you see our angles are coming here. We have already pointed the need why we are discussing the angular relationship not to estimate the solar radiation. So in our estimation H0 is coming. For estimating H0 we need all these things. Okay, ISC is you can take the constant 1.37 kilowatt. Then this one n is the day number, omega is our angle, phi latitude angle, delta declination angle. So these angles you can calculate using the relation. Okay, phi etc already will be given for the location. Declination angle you can calculate, hour angle you can calculate using the relation given in the data book. So that is why I asked you to note down the required relations into your notebook also. Okay, another terminology is we can have, what is this, S dash and S dash max. What is S dash? Monthly average solar day length. Sunshine day length means sunshine hours. How much time the sun rays are available in a day? So in a day 8 hours, 9 hours, 7 hours, it depends on the locality and also the season, right? So that is maximum will be given, then long monthly average solar day length, that is usually given, but S dash max you can calculate longest day in the month in hours, right? So this you can note down this relation. What is the relation? Using these definitions you can get a correlation, page angstrom correlation. This one, Hg dash by H0 is equal to A plus B into S dash by S mass. This relation, okay, that is page angstrom relation. This relation you can modified angstrom relation, that is called page angstrom correlation. Hg dash by H0 is equal to A plus B into S dash by S max. This relation you take into your notebook. Is it visible to you, everybody?
Yes, sir.
I understand that people from all the streams of engineering are here, not only mechanical, right? computer science. Is it okay to follow this topic, everybody?
Yes, sir.
It will be boring at the first, but you read the PDF and we will do some numericals, then it will be clear, right? It's easy only, but you will have to understand so many angle terminology as well as this correlation equations. So that relation you can take into your notebook. Okay, Page-Angstrom relation it is called. So Hg dash by H0 is equal to A plus B into S dash by S max. So in that A and B are constants. People have already made this constant for different locations. In your data book, you will get that value for a given location in India as well as many parts of the world. So what is our interest? We want the monthly average global radiation, that is Hg dash. So this is a function of, as per this correlation, this Hg dash is a function of H0, then X max, then the two constants A and B. So H0 we can calculate it using the relation. Already we have seen the H0 is equal to another relation is there, no? ISC function that you can use. A and B you will get from data book. S dash and S max. What is S dash and S max? Sunshine hours, maxima and this one. Definition is given no here. What is S dash? Monthly average solar day length, sunshine hours. S dash max is longest day in the month. So this one monthly average solar day length we can measure for our locality. S dash max you can have another equations. Okay, we can have this relation. Previously we have defined. S dash we can sorry, I have made a mistake. S dash we can calculate using this relation. S dash max will be given in your question. Okay, maximum sunshine hour will be given. Average on the locality you can calculate. S is equal to 2 by 15 cos inverse minus tan phi tan delta. So you can calculate our angle. Then using this equation you can calculate sunshine hour average on the locality. So all the other variables we will get either through equations or from chart. Then you can calculate monthly average global radiation. What is the unit? Kilojoule per meter square day. Right. Kilojoule per meter square day. So this is the graph showing annual, daily, hourly curves of measured global radiation. You can see time of the day, time in the day. At various time, morning it starts from 0, then it increases in the peak noon, then it decreases. So this variation is there. Annual, daily, hourly curves. Daily curve means like this, and this is the annual hourly curve. So solar radiation highly fluctuating depending upon the time, latitude, right. All these angles are functions of global radiation availability. Shall we do a numerical problem on this one? Now?
Yes, sir.
So you can take this problem. I will upload the slide. So is the slide visible?
Yes, sir.
Yes,
So
sir.
okay, estimation of solar radiation. So this is there. So we have defined these angles. Okay, phi latitude angle, sunset hour angle omega s, hour angle omega, declination angle delta, incident angle theta, tilt angle beta. So declination angle, I will revise. Declination angle delta is equal to 23.45 sine 360 into 284 plus n by 365, where n is the day number. Okay, in the year which day we are considering for our solar radiation availability calculation. Day length means omega s cos inverse minus tan phi tan delta. The time between sunrise and sunset, that is the day length. It depends upon sunset and sunrise time. So sunset and sunrise time is given by sunset hour angle omega s cos inverse minus. So in a given location, how much is the time between sunset and sunrise? It depends on the location. No, everywhere it is not same. So that dependency is expressed in terms of declination angle and latitude angle. So it is given by cos inverse omega is equal to cos inverse minus tan delta tan phi. You can put the other conditions into the main equation and get this relation reduced, okay, into this form. It is obtained from our main equation. Then day length is equal to, yes, 2 by 15 omega s. It is by definition of the day length. Then by we have ISC dash is equal to ISC into 1 plus 0.33. This is the corrected. ISC dash means corrected value of solar constant. Okay, solar constant is not actually constant. It also varies little bit with the time of the day or day of the year. So it is given by this equation. ISC is a constant 1.3 value. Okay, kilowatt per meter square. We will correct it by this equation. 1.36 kilowatt. Then this is the correlation we discussed. Page-Angstrom method of estimation. Hg dash by 0 is equal to A plus B into S dash by S mass, kilojoule per meter square day, where S0 is equal to monthly average extraterrestrial radiation. S mass is equal to longest day length in the month in hours. S dash is equal to monthly average sunshine hour per day. So S dash we can calculate using 2 by 15 omega s. Then H0 is equal to 2 by pi ISC into this relation. Okay, so this is the equation and angles needed for your estimation. You can take this numerical problem. Estimate the monthly average global radiation on a horizontal surface at Baroda. Baroda means near Gujarat, right? In India. So the latitude and longitude is given. 22 degree north, 73 degree 1 minute east. Estimate the monthly average global radiation. If the average sunshine hour per day is 9 hour. So average sunshine hour is given. S max is given. You can get A and B value from the data book for Baroda. H0 you can calculate so that you can get a Hg dash. Hg dash we want to find out. Will you be able to do it as a homework? 53 students.
Sir, we need to find HZ, right?
HG dash we have to find. So this problem we will do in the class. I will give another problem for your homework. So
Yes, sir.
estimate the monthly average global radiation on a horizontal surface at Baroda. So in this problem, which month is not given, right?
Yes, sir.
Monthly average global radiation for the month of March, like that you can rewrite. Okay, it is a missing entity for the month of March. Otherwise, it is meaningful because different time of the year it is varying. No, so we have to specify which month. Monthly average means which month we have to take it. So estimate the monthly average global radiation in the month of March at Baroda. Like that you can redefine. So March means each month there is a specified day. Okay, for getting the monthly average. So March 16 in your data book it is given. Okay, for people have defined in each month which day we will consider. Okay, because we have to put n value in the equation. N means the number of day in the year, right? So March means for getting average for March 16 is taken. So n is equal to 75. So if it is January 17, February means February 16, March 16, April means April 15, May means May 15. So in around middle, okay, 15, 16 like that. Towards December, I think December 10 is taken. So this is the optimum day which we should consider for getting most accurate answer. These are our correlations, so we will not get the exact, but we will get try to get the maximum accurate answer. For that, these are all the recommended days. Is it clear? So you don't have to by heart it, which are all the days for consideration. It is given in the table. You can refer that. Okay, so March month means March 16 we will take. So n you can calculate. January 31, February 28. So 31 plus 28 plus 15, 16. So 75 you will get. Then you can calculate declination angle. Delta is equal to 23.45. Sine 360 into 284 plus 75 by 365. So you are getting minus 2.42 degree. Declination angle is minus 2.42 degree. Are you getting it? Yes or no?
Yes, sir.
You will have to use your calculator. You are ready with your calculator? So check whether you are getting this one. So this is the minus 2.42 degree declination angle for the given month at the given location. All these are specified. Okay, minus 2.42 you are getting because of that phi angle and that day. Okay, considered day. Now we will have to get a S value. Okay, sunshine hours. 9.5 hours given. S mass you can calculate. S mass is equal to 2 by 15 omega S. So 2 by 15 into omega S is given by minus cos, sorry, omega S is equal to cos inverse minus tan phi tan delta. Phi is given. What is phi? Latitude 22 baroda 22 degree given. Delta we have calculated minus 2.4. So you will get easily S max 2 by 15 minus 2 by 15 cos inverse minus these angles. So 11.87 hour you are getting. Omega s, you are getting cos inverse minus tan phi tan delta. So omega s is equal to 89.08 degree. 89 point, whether you are getting that one, omega s? Omega s is this term, my cos inverse minus tan phi tan delta. Tan phi means tan 22. Tan delta means tan minus 2.4. Okay, delta minus 2.4 we already calculated. So cos inverse of that means you will get 89.02 degree. So that degree, 89.02 degree, we want to convert into hours. So 2 by 15 into 89.02, that much hours. So
Excuse me, sir.
yeah,
Sir, how did we get that phi angle as 22 degrees?
that is given in the question. Phi angle means it depends on the location. So location already given, no. Baroda means 22 degree north, 73.1 degree east. It is given. Right. Phi angle. Is it clear?
Yes, sir.
So north means phi. Okay. East means longitude angle. Like that you can consider. So this is that our angle. You check once with in your notebook. Okay, you will get this value. So corresponding hour is 11.87 hours. Maximum theoretical maximum solar rays availability is 11.87. So actual solar rays availability is 9.5 given. Okay. In the question 9.5 given, but theoretical maximum 11.87 we can expect. So we can put it in our correlation. So what is the correlation? Hg by h0 is equal to a plus b into s by s mass. So where a is equal to 0.28, b is equal to 0.48 from table. You check the table, you will get these values for Baroda. 0.28 and 0.48. So you put it in the equation, this one. H0 we got, no? What is H0? H0 we didn't find out. H0 we have to get, okay. Yes, for H0, you have the long relation, 2 by 15. So we will continue with this problem next class. You try to solve it your own using the relations given in this data book, and we discussed in the class. Try to solve it. Obviously you will get a doubt. We will try to clarify in the Tuesday class, right? In fact, similar problems are already solved in the PDF. Okay, PDF also you can read.
Yes, sir.
Okay, sir.
Okay,
Sir, can you upload this PDF even?
this PDF I will upload today.
Yes, sir. Thank you. And the previous one even, sir, from which you explained those all things.
Yes, yes. I will upload this one. Only few students are asking, what about others? Everybody others are getting this idea.
Yes, sir.
So I upload this PDF today. Everybody read and come for the next class.
Okay, sir.
Yes, sir. Thank you, sir.
Okay, thank you.
Sir,
Yeah,
you will be uploading all the PDFs, right? All the class material on VTalk.
all the class up to this class already I have uploaded.
Okay, so actually, yesterday and day before yesterday, I was checking. I did not find it. Maybe now it was updated.
It is updated. This one I will update evening. Okay. So you take the printout of the data book. It is needed for your exams as well. Only the page that I have mentioned yesterday, not the entire book needed for you. Estimation of solar radiation, sun earth geometry, that is needed. Okay.
Sir, one more from which today you explained, no, sir. That also you can upload, sir.
Yeah. This also I will approve.
Yeah, thank
Okay,
you.
sir.
Okay, thank you.
Thank you, sir.
Thank you. So you can leave now. Okay.
Thank you, sir.
Okay.
Thank you, sir.
Thank you,
Yes.
sir.
Thank you.
Thank you, sir.
Thank you, sir.